simple problem related to a Norton's theorem. So listen the question. So find the current through the 2 ohm resistor using a Norton's theorem. So in your question it is given that 2 ohm resistor. So that is nothing but your load resistor. So whatever the resistor given in the question is considered as a load resistor, that is RL, and we are going to find out the current which is flowing through this 2 ohm resistor using Norton's theorem. To find the current value, the step number 1 based on your Norton's theorem is remove the branch which is asked in the question and redraw the circuit. For step number 1, remove the load resistor RL and mark the terminals as A and B. So redraw the circuit, which is 28 volt 4 ohm resistor. Here we have 1 ohm resistor and 7 volt voltage source. So remove the load resistor and mark the terminals as A and B. So this is step number 1. So in step number 2, as per the Norton's theorem statement, you have to short circuit all the voltage sources present in your circuit. We have 2 voltage sources, one is 28 volt and second is 7 volt. Now we have to short circuit this voltage source and find out the value of Norton's equivalent resistance. So it is short circuited here. So this is A and B, and we have 2 resistors, one is 4 ohm here and second is 1 ohm. So from this circuit you have to find out the value of equivalent resistance. So just observe the circuit. We have 4 ohm resistor is in parallel with 1 ohm resistor. So Rn is equal to 4 ohm in parallel with 1 ohm resistor. So 4 into 1 divided by 5, that is 4 plus 1, you will get Rn is equal to 0.8 ohms. So this is my Norton's equivalent resistance value, that is Rn equal to 0.8 ohms. So next is to find out the value of Norton's current In. So for that we would redraw the circuit again as step number 3. So this is my 28 volt and this is my 1 ohm resistor and this is my 4 ohm and 7 volt. So for this step, to find out the value of In, you have to short circuit the terminals A and B. So this is my terminal AB, you have to short circuit this point to find out the value of Norton's current In. So just observe here, we have 2 loops which is considered as I1, and for second loop the current flowing is I2. Our objective is to find out the value of current which is flowing in this short circuited path. So try to find out the value of I1 and I2. So I1 is equal to, so just apply Ohm's law. We have a 28 volt and 4 ohm resistor. So I is equal to V by R. You will get 28 volt divided by 4 ohm resistor, which is equal to 7 amps. So this is my I1 current. Similarly for I2, again Ohm's law. I2 is equal to, we have a voltage source as 7 and resistor as 1 ohm. So you will get 7 by 1 I2 as again 7 amps. Now just observe this circuit. The current which is flowing in this short circuit path can be written as In is equal to I1 plus I2. You will get the Norton's current In equal to 7 plus 7, that is 14 amps. So this is my Norton's current value. So final step is to find out the equivalent circuit of Norton's theorem. To draw the equivalent circuit as per the Norton's theorem, you have to connect the single current source in parallel with the single resistor. So my single current source value is, here I have calculated 14 amps, and single resistor is nothing but Rn value, which is equal to 0.8 ohms. So this is my Norton's equivalent circuit. But the question is, you have to find out the value of current which is flowing in the 2 ohm resistor, which is nothing but a load resistor. So you have to connect this 2 ohm resistor finally in parallel with your Rn value. So load resistor is 2 ohm. So to find out the value of current which is flowing in this 2 ohm resistor is IL is equal to, using your current division formula, so total current I into the opposite branch resistance, that is 0.8 divided by total resistance 0.8 plus 2. So you will get the IL value finally as 4 ampere. So this is my final answer. So thank you.